Hello, I've created a game, and within this I have produced various gameplay features. The first feature is a spellbook. This is a collection of data that is then used to control a selection of different variables of the spells. These would be fire rate, damage, range, projectile speed, and duration. I then use this data in the creation of the spells themselves to alter their stats. The second feature is the ranged combat. This utilizes the data from the spellbook to set the range and the damage of the selected prefab. So when the player presses it with Unity, I believe this was a good pick for my project because it had lots of help and features that are good for making 3D games. An advantage of using Unity was the community. There is lots of help and tutorials that are linked with it, and Unity itself has a lot of videos that would help to make your game better. Another advantage of using Unity is the cross-platform power. This allows games that were made for PC to be ported over to other devices easily with almost the click of a button. One of the disadvantages, however, of using Unity would be if I wanted to make a big project. Unity is not designed for massive AAA games, but for indie developers. The other platforms I considered using were GameMaker and Unreal Engine 4. GameMaker only supports 2D games, and I wanted to make a 3D game, as I have not made one before. Unreal Engine is used by big companies with large teams. This is also used to make hyper-realistic games with good-looking graphics and requires a lot of power to run. I did not want to make this type of game, as the plan was to make a more goofy looking version of Diablo 3. I decided on Unity as I have some base knowledge that I would be able to build upon and lots of self-learning opportunities. The actual gameplay elements that I included. When I first started coding the spells, I had the raycast do the damage on contact. This raycast would come from a first person camera that was not active. This camera was not active because of the style of my game. I had to make a new camera that would act as the first person camera, and the raycast would come from that instead of the main camera. With this raycasting method, I had a problem with the damage. The damage would take effect when the raycast hits, not when the spell hits. I incorporated a delay that would do the damage when the spell hits, but after playing around with it in the game view, I found a problem with this method, and that was the further the player was from the target, the bigger the delay would be, and the same for when the player was too close to the target. After doing some research, I found a better way of doing this, and that was to put the damage on the prefab and cool it when it hits the target. I believe doing it this way is much better than when I had before, because this allows the code to be used on other spells didn't I, and I don't have to create a lag between when the raycast hits the target and when the spell hits the target. I followed a tutorial to make a chain lightning attack, but this tutorial was from a 2D game. I thought I would be able to use this as a base and find a way to get it to work in 3D, but for some reason it did not work. I believe there was a problem with the rest of my code and how I set it all up in Unity. Due to the fact that I could not get the chain lightning attack to work, I started to look at other spells I could use. One of them was the Fireball spell, a simple spell that would affect the area around the impact point. Using physics.overlap sphere, I would create a temporary array that would store the data of the objects nearby that were on a certain layer. Once this array was made, I then used a for each loop which took in the data from the colliders, and then used my damage script to deal damage to the enemies. While trying to make this, I ended up making another spell. This spell was the Ice Spike. This works in a similar way, but instead of damaging the enemies around the collision point, its damage is increased with the amount of enemies above 2. So if there were 4 enemies around the target takes 5 extra hits. This in turn turns Ice Spike into a single target nuke ability. Due to all the spells inheriting from the gun script, it was easy to make other spells like the Grass Trap and the Heal. The only thing I would need to change would be the code inside the spell itself. Another reason it is easy to make more spells was due to having a spell book. This was an array that would hold certain pieces of information about the spell, such as what prefab to use, the spell's fire rate, the spell's move speed, and other stats. Due to the fact that I had 2 cameras, I realized I could make the game switch between 2 different perspectives. This would allow the player to see from a top-down view and also have a first-person perspective of the game. After implementing this, I realized I could have done a better job if I had planned to have this from the start, as I could have used a finite state machine to control what state the player and the camera were in. This would have allowed for 2 sets of separate controls, a mouse movement for the top-down view and a WASD controls for when the player was in the first-person view. As stated at the start, I did have a few problems with another part of my code, and that was the finite state machine that controlled the damage over time effects and the debuffs for the enemies. One of the problems that I did overcome with this was the coroutines. Coroutines require the script to be derived from a mono behavior, but my state machine was not part of this behavior. But by researching the problem, I found out that I needed to use GameObject.findObjectType mono behavior. This would search other scripts for a mono behavior and use it for the coroutine. Even when I used this, I still could not get the state machine to work, and due to time constraints, I had to give up on using this because it was taking too much of my time. How my code is professionally relevant. I believe some of my code is professionally relevant because it's easy to read and understand. Within the gun script, I used lots of classes to make sure that one single class does not hold too much information and data at once. I let one function perform only 1 or 2 tasks. This in turn makes it easier to read and debug. Another thing I tried to do with my code was to keep going back and reading it to see what is not needed, to check if there were anything left over from testing code, checking to see if variables were in the right place. This is to make sure that the code I am making is clean and clear to anyone. I tried to use meaningful names for all the variables, functions, and methods, such as fire rate fireball instead of FRBF or fire rate BF. Finally, one of the best ways to keep code professional is to make sure it's readable for people, which I believe I have done. By using the methods above, it has allowed my code to be easy to read, which in turn allows for easier debugging. One of the big oversights was lack of planning my code and the project in general. Planning is a big part of games, and better planning would have allowed me to make certain parts of my code, such as camera swapping and having a different control scheme for them both. If I had planned to do this from the start, I would have looked more into a finite state machine to control what state the player and cameras were in. This would have allowed me to swap the controls very easily, and they would have not interfered with each other, as the player would only be in one of the 2 states. One of the things I did which might not be professionally relevant, but would have been relevant in a workplace, and that was to understand code that I have learned from somewhere else and placed it into my project and managed to get it working. The main point of this is that I understood what I wanted to do and what the tutorials were showing me, but I managed to expand and evolve the code into what I wanted and make it into my own. The practical exercises, and if I conducted further practical research. I managed to do most of the exercises that were set. After Christmas, I focused more on doing more of my coursework than I did of these exercises, as I believed that was more important because the deadline was coming up. I did have a few problems with some of the tasks, but I used the internet to look up what solutions other people have done and see if it fits with the tasks I have been given. Some of the tasks were relevant to my project. One of these was the raycasting. As I used raycasting at the start of my project to get the spells to move and hit the correct target, I tried to incorporate a finite state machine into my project, but I had lots of problems trying to get coroutines to work. But after lots of research, I did make it work, but it did not work the way I wanted, so I decided to give up as it was taking lots of time. The last exercise I did before I started working on my project was the delta timing exercise. Within this exercise, you need to make it so that the game would slow down while the player is moving. Some of the practical research I did was to follow the LinkedIn Learning lessons on object-oriented design principles. These lessons help to enforce aspects of coding that I missed out on in the first year of uni and from my college course I did. One of the things I missed was inheritance. I might have been doing it before, but I did not understand the proper use and correct way to use it. Overall, I believe that the project I did was alright, but it would have benefited from better planning at the start, and if I had a clear plan for the whole thing. This will be something that I will work on and try to implement in the next project I do. The other thing that I did was to use tutorials for some of the features, but I changed the code to fit better with what I wanted. I then expanded the code past what it was originally intended to do, and then used what I had learned from these tutorials to make more code that would work with other parts of the project.